You don't know what I'm going to say yet, so you might want to hold that applause. Hey everybody, I'm Lee Holmes. I'm the lead security architect of Azure Management. So today we're going to talk about how many people here have heard about how crazy awesome security has gotten in PowerShell version 5. One clap. So what we're going to talk about is you're going to come to a situation, either you've been asked by somebody at work, like, we just got rolled by a PowerShell attack. How do we defend against these PowerShell attacks? Or you're going to hear something in the media and somebody's going to ask you the same thing. But really importantly, if you're in an engagement and doing this from a red team perspective, our job as an industry is to not just walk over people and leave them with their heads hanging in shame, right? Our goal is to actually improve them, right? So what we're going to talk about today applies whether you're doing this from a defensive perspective or if you're actually trying to walk out from an engagement better than when you came in. Now, to get going on this, we're going to talk a little bit about really what the deep, dark depths of PowerShell attacks look like. So we're going to dive a little bit into the abyss that is PowerShell attacks. Unsurprisingly, this is kind of how it starts. Here's a typical phishing, Word doc kind of thing. Somebody is lured to click enable content. But what really happens when they click that button, inside here, you've got VBA. It's a disgusting language, but it does its job. It's got full access to Win32 APIs. It's got, I've seen a PE loader, a full PE loader written in VBA. When you've got a macro running in Office, you have the exact same capability that you have with a regular Windows application. What you see in this one, though, at the very top, there's an example where this person has downloaded, they're calling the API to download a file, and they're just doing a very simple shell execute on that file. Once they got in the door with the macro, they're just running a regular old exe. So this was not a word attack. This was really an executable attack when it comes down to it. Sometimes they try to get a bit tricky. So here's an example where rather than going out to the internet and calling Win32 APIs to start downloading files, instead it just packs all that stuff into some base 64, decodes it, dumps it as an executable on the file system, and runs it. So you're kind of seeing there's a bit of a pattern here on the way that people are working. Now, a couple little words changed here. Rather than running a regular exe, they're just running PowerShell-encoded command or PowerShell-command with that base 64. So before they used to dump it as an executable on the file, got past everything. But now, since they like to have fun with life, they're calling PowerShell. This is now a PowerShell attack, and you're completely owned because it involved PowerShell, right? Now you might be wondering, what does APT look like? That's commodity malware. What does the real, actual, hardcore APT look like? So here's a great blog post from FireEye. They dug in, they always do this. They dig into big things. When you take a look at an example of the things that actually get them in the door, it's commodity malware. It's a macro dumping an exe on disk and running it. Or it's a macro taking some base 64 and dumping it into PowerShell and running it. So the same things that you might denigrate in terms of what is a commodity attack versus a more advanced stuff, this basic stuff works all the time. Palo Alto Labs did a really awesome investigation recently. So when you start talking about PowerShell attacks, right, where do they actually start? We just showed you that they don't start with somebody popping a machine from PowerShell itself. PowerShell is never that initial entry point. It's always something else that already had full control of the operating system. So Palo Alto, they run this email scanning gateway, and they took a big look at what were the actual sources of compromise that led to what people were calling a PowerShell attack. So you see here the numbers are stunning. It's, okay, it was an exe that launched some PowerShell. Or it was a DLL that launched some PowerShell. Or it was a Word doc or a macro that launched some PowerShell. So whenever you hear anybody talking about a PowerShell attack, really what they're talking about is just a regular old attack. It's an exe attack. It's a assembly attack. It's a x64 attack. It's just somebody misusing Windows. However, One place that PowerShell has become really, really useful in terms of magnification of PowerShell is a really great set of post-exploitation frameworks. There's like half of the authors in this room today, so if you want to know that you're rubbing shoulder with greatness, that's what it is here. So this is one of the things. So that's the truth of automation, is it's an amazing amplifier of power. Automation never changes what you can actually do. People could always do this stuff by hand and very slowly. But one of the things that's been true is this blossoming of post-exploitation languages and frameworks that let the people that you're spending, $100,000 on an engagement to help compromise your company, they're now way more effective at doing that exact same thing. But they use PowerShell because they have job satisfaction. It's a fun language. It's got easy access to things. Like, it's just a fun damn thing to work in. So that's why people do this. But that's not the only options you have once you've compromised a machine. So once somebody's got that initial entry point, you're not just talking about PowerShell. If you get rid of PowerShell, you still have all these things, just exes, like straight up exes. That's very, very successful. DLLs, just a bunch of other things. Who's seen the MITRE attack framework here? It's pretty awesome. This does a better job than I could ever do that talks about really what is your scope and what is the impact of post-exploitation tools. So they've broken this into a bunch of different things in terms of once I get onto a system, how do I do some lateral movement? How do I do some code execution? So this is a great example of like, most of this is not PowerShell. But this is what you hear, right? Of course, let's block PowerShell. It's the thing that gets the news. People literally can't keep up. AV companies cannot keep up with the amount of XCs and DLLs out there. So what they'll instead do is they'll talk about some fun encoded PowerShell and like stuff that seems like really breaking so that they can show that they're like modern on research. But realistically, they just can't keep up with the stuff. And so what you hear about are the PowerShell attacks. So people will say, let's block it. Of course you want to block it. It feels like a painful thing. But here's the core thing, right? This is like, it doesn't solve the actual security problem that you ran into. I just showed you 2 pages of ways that any attacker at all interested in a system had other ways to do exactly the same thing. They could have come in from PowerShell, VBA, macros, XEs, DLLs, anything. It's just like the world is their oyster. Blocking PowerShell is not going to solve the underlying security problem. But here's the big trick. Blocking PowerShell removes your single most security transparent management engine that exists on Windows. Matt put it really great this morning in the keynote, saying like, I challenge you to find any single language, scripting language, management framework, anything that gives you the degree of security intelligence into what's happening on your system compared to PowerShell. And the thing is, blocking PowerShell straight up, PowerShell isn't just PowerShell.exe. Here's a great example of PowerShell truly is a management engine, and one interface to that engine is PowerShell.exe, but there's other ones. You've got Visual Studio Code, you've got the PowerShell ISE, you've got Bandana has is not PowerShell, it's kind of a fun thing. Here's an example of treating, hosting a PowerShell engine inside of a simple WinForms application to do some kind of graphical stuff. So in the end, you block PowerShell, this is what you get. MITRE attack framework does talk about WinRM as your lateral movement block. You can talk about PowerShell there. So you block that. How do you think you're going to do at the end of the day against any sort of attacker? Not going to do very well. Here's one example. You can read that, right? These are all the tools that embed the Lua scripting language. Guarantee you have tools in your environment right now that rely on Lua. Like, what can Lua do? Maybe it's just a neat thing. You can pop calc with Lua, no problem. It's a full-on scripting language that can do anything that you could ever want to do. This is an example in Nmap. It embeds Lua, and you can do all kinds of scripts in there. So Lua is pretty awesome. It's everywhere. There's no logging. Do you want attackers going to that instead? I don't think so. Now, one of the things that's important to think about is there's really 3 stages in security. We've spent a lot of time in the last, years and years and years talking about prevent. Prevent isn't enough, right? You really start talking about preventing is important, but if that's the only muscle that you have, then it's game over the minute you're compromised. What you also need to build muscle on is detect. You need to build muscle on remediation. If all you're doing, blocking PowerShell is saying, I know I got compromised. I got compromised. I had an arbitrary word macro running in my environment that could have run a full PE loader. I got it, I'm compromised. But I want to block PowerShell. You're just putting more muscle into the block. What you want to be doing is to say, okay, well, if that bad thing happens, what's my options? How do I start to push people into the world where I'm better at detecting and better at remediating? So you might think that I'm a PowerShell apologist, but I'm not. We're listening. That is true. All this stuff is true. If you're compromised, whatever. But we have spent the last 10, 15 years solely focused on PowerShell security. We've done an amazing amount of things of the language and commandlets and management and all that kind of stuff. It's like freaking awesome. But we have spent so much time investing in PowerShell security. As we talk through the rest of this talk, I challenge you, think through, what does this look like for Python? What does any of this look like for Perl? What does it look like for XEs, DLLs, any of that stuff? PowerShell, we've done a ton of stuff. I'm going to go into it right now, but nothing else even comes close to comparing. But there's an interesting invention and an interesting update on this. What just changed here is Python. Microsoft runs some Python in Azure. We started working with the Python community to bring a bunch of this security transparency stuff into the Python engine itself. So that's out there as PEP 551. If you're interested, take a look at it. File some comments, whatever. So we're actively working on this, so we'd love some feedback if you've got it. So let's talk about some of the things. PowerShell, it's great, it's awesome. What can you do when you actually want to start detecting and defending against these PowerShell attacks? The first one is just enough administration. It's awesome. Everyone always asks, what do I do? If I've got all these administrators, what do I do to make them not so administrative? I'm just, they end up compromising my infrastructure. And you say, just don't make them administrators. So this guy in the top left, who knows him? Benjamin Delphi, who knows him? Mimikatz, who knows him? He's a great guy. This isn't a slam on him. It's just, he's a persona. He's fine with this. So imagine Benjamin Delphi. He's your DNS administrator. And he says, that's a bad idea, right? He tries to remote desktop into a server, access denied. He goes to our knight in shining armor, Jeffrey Snover. He says, Jeffrey, I need to RDP into the DNS server. Here's the thing, DNS tends to be co-located with AD. And so you give somebody DNS administration, which is kind of a small thing. You're usually giving them domain admin. So he says, Jeffrey, please, I need to do some DNS management. Let me RDP into your domain controller so I can get my job done. Of course, Jeffrey's not born yesterday. He's like, just use PowerShell Connect, you'll be fine. He connects up. He's able to restart the DNS server. Things are all good. He's happy. Jeffrey looks away for 1 minute, tries to steal some secrets and do some bad stuff. Access denied. It does not work. This is literally possible today. You can have a DNS administrator connect using PowerShell to your domain controller, and you have no risk to your domain controller itself. So the way to think about any of this stuff when it comes to administration is that your exposure is kind of a combination of 2 things. It's the time that somebody has administrative access to the server, and then it's also the capability that they have when they're connected to that server. So as a industry, we're getting pretty good at the time thing. So we have things around, oh yeah? I came prepared, buddy.
Oh no, you don't risk me, I see you.
I did not. I got it even better. Okay.
Oh yeah.
Get nice to ice, ice, baby.
Yo, VIP. Let's kick it.
It's been a while since college. I guess I should shut this song down. But it's a good song. Where were you? PowerShell, something about PowerShell. So we've done a pretty good job as an industry locking down the time thing, right? This is the privileged identity management. Yeah. Is this better? Nope. Start again. From scratch. So we've done a pretty good job from when it comes to the locking down the time. And we're doing pretty good there. GIA is the way that you can lock down the capability itself. This wasn't actually that bad. I thought I was going to regret this. So the capability, this is what GIA is all about. So we've done a good job at constraining time, but what if you can also constrain the capability? So rather than connecting up as a full-on administrator, what if you can say, well, yeah, you can't run Mimikatz there, but what you can do is run some DNS stuff. So you might say, that sounds great. We've been trying to do RBAC for 40 years in the industry. It's never going to happen. How about this? This is what it looks like to actually define that capability restriction inside of GIA. You give it a description, maybe which PowerShell modules you want to import. Here's an example of saying this person has access to a handful of these commandlets and maybe some custom functions. Does anybody think that they could write one of these things? Of course you can. Give yourself some credit. Anyone here could write this damn thing. So that's what a role capability looks like. So you can do this over remoting connections, but what you can also do is do local sandboxing, so that anytime a local PowerShell is run, this is really useful in something like a jump box scenario. Anytime a local PowerShell is run, it will automatically go down and then use the GIA configuration for that user. It's pretty amazing. So when you can do the two things together, now your security exposure, you used to be pretty happy about having the restrictions on time, you combine that with the restrictions on capability, and like your security exposure is minuscule now. One of your DNS admins gets popped, this is the time at which you're vulnerable. It's pretty epic. Yeah. Got 2 rooms full. So, another big thing, so that's GIA, right? So a big problem is administrators running amok. GIA is a great way to start controlling what the admins can do. But then you've got PowerShell's security transparency. And my favorite story about PowerShell's security transparency was Mandiant, they presented a couple of years ago, No Easy Breach. So this was in the midst of a customer getting just completely rolled by APT29. They knew that APT29, as they would try to remediate a machine, the next one would get popped basically as soon as you could imagine. So the APT29, they were using XEs, Python, PowerShell, like just whatever they could find. It was just like this just carnivorous thing ripping through the infrastructure. They did one thing to this customer. They installed PowerShell with all of its logging, turned it on, and this fog of war went away. Immediately, the whole thing became an open source investigation. They just looked at their damn logs and checked out, and they could see where everybody was connecting to, what scripts they were running, what credentials they were using, everything. It is crazy, the kind of power that you get from this. So the first thing to do is to start configuring this stuff. Like, attackers aren't in the habit of configuring it for you, so you might as well get started on your own. Configuration is a simple group policy. You can also do it with the registry. You can do it with PowerShell DSC. There's a ton of different ways to configure this stuff. Now the first one is module and pipeline logging. This shows every commandlet that's run. It's a pretty noisy one. It's something that you might want to keep locally and maybe do some local intelligence on. But this is a pretty great thing. It shows the unobfuscated commandlets as they're being run. System transcripting, you can enable this. It's kind of gives you the equivalent of an over-the-shoulder view of what's happening on a machine. So if you were literally standing behind somebody and saw what they were typing, saw the output, this is what you're going to get. You can set this up to log to another machine, and we even have a script on a blog that we did, the PowerShell Hearts the Blue Team. Has anybody here seen the PowerShell Hearts the Blue Team? Sweet. Check it out. It's a pretty deep article. It's going to take you a while to chew through it, but we've even got a script on there that lets you create a file share that gives people kind of like this black hole. They can write stuff into it, but even if they're later compromised, they can't even read the stuff that was previously written by them. If an attacker takes over a machine, they can't enumerate the file share to see what happened with anybody else. So it's a pretty good thing. You get this stuff going, get it off into a system, you can do analysis on it. It's all text-based, so you can grep it, do whatever you want. But one thing that's really epic is script block logging. So when you turn on script block logging, here's the thing that tends to happen is some malware initially will run onto a machine, and then it will do a thing of downloading some more content and running that, and more content and running that. Each one of those takes a trip through the PowerShell engine, and the key thing that we did is every single time PowerShell is asked to run anything, it goes into the log. It sounds simple, but like nothing's done it. We've done it. PowerShell's done it. So anytime something is deobfuscated, taken from the internet, everything anybody says is like, oh, this is in memory only. It's not. This is logged like crazy into your event logs if you've got it enabled. And it becomes the best deobfuscator money can buy. Here's a great example from invoke obfuscation from Daniel Bohannon. So this is an example of taking a chunk of script, sends it to the blender, it looks ridiculous. Now take a look at the very, very top left. That's kind of a funny encoding for invoke expression. If you've got PowerShell script block logging enabled, very next thing you're going to see in the log is exactly what happened. That trip through invoke expression, it took one more pass through the PowerShell engine. The PowerShell engine says, oh, I'm going to log this. So you get to see and write your rules against deobfuscated content. You don't have to worry about deobfuscating it by hand or any of that. PowerShell does it all for you. Now what if, so anti-malware, right? What if all of that was available to anti-malware? Like we're all aware that anti-malware tends to go off a file being read from disk, but that's kind of the problem is malware forever has had to go in and kind of dig into the engines and try to figure out what's happening there, is it malicious or not? But with Windows 10, there's a new platform feature called the anti-malware scan interface. Now that's a new API that any application can call into and say, I'm about to run this content. Is it safe to run still? So now applications become active members in their own defense. So in this situation, maybe PowerShell reads a script off of disk. AV thinks it's fine. And then that script goes and fetches something from the internet. AV thinks it's fine. Then it goes and deobfuscates it. Maybe that core nugget past all that obfuscation is the thing that AV can finally flag on, and it works. This is detecting tens of thousands of hits of people doing this stuff every single day, and because of the anti-malware scan interface in Windows 10, now they're being protected. But you might wonder, with all this sensitive data running around, what happens if an attacker gets on the machine and starts taking a look through all of my logs, right? Is that going to be an information disclosure problem? But you've got a good option here, and that's protected event logging. So protected event logging, it builds on the magic of public key crypto. So public key crypto works under the idea that the key that you use to encrypt data is different than the key that you use to decrypt data. So the idea there is I can say that everybody in the world can have the encryption key. I just really don't care. It's a one-way operation. I deploy the encryption key to every single machine in my network. You can do this through group policy by either just like the base 64 content. You can point it at the private key, the public key on a file share, anything like that. That protects your logs. So this is what it looks like when you're actually looking at this on the local event log. But then the magic is you have all of these things forwarded to your central collector. That is the one thing that has the private key. Then you can decrypt all this stuff without having to worry that an attacker ever saw it. So it's a pretty sweet thing. Now, when you're starting to deal with event logging, a big thing to think about, there's a bunch of useful events. So there's a great post out there also from FireEye. We worked really closely with them on putting it together. Here's a bunch of great PowerShell events you can use in your investigations. The one thing that people are starting to make the mistake of, we have the 4104 event is the script block logging event. Now the thing there is that we also have some built-in intelligence where we took a look at script block expressions and terms and stuff that were used in commonly used malware. Inside the engine, if PowerShell ever sees that, well, it logs that script block anyways. Even if you hadn't remembered to turn on script block logging, it's going to log it anyways. That's not your intrusion detection system, right? This is like a set of static rules people have and will get around those static rules. It ships as open source. Anybody can figure out what it is, but it's a great stopgap. So it's a good thing to be looking for, but not relying on. But from that perspective of, by the way, you guys are all paying attention of like, did any of this exist in Python or Perl or Xyz or C# or assembly? It's pretty crazy. So the other thing to think about is PowerShell is amazing as a language that lets you do things that are more than just regular expressions. Now, one of the great opportunities there is when you start to get into, a lot of people will dump all their stuff into a SEM and like just let rules hit and all that kind of stuff. But they're missing this amazing opportunity, which is take all this PowerShell to a collector and maybe do some post-processing of the event logs before you send it off to your IDS. So here's an example of 2 examples of obfuscated PowerShell scripts. They look pretty crazy, right? You might wonder, how can I possibly detect this kind of stuff? This is one way. PowerShell is one of the only languages that I'm aware of that fully exposes the actual underlying structure of what it understands your script to be. It is no longer a series of text and all that kind of stuff. When PowerShell interprets your script, it first breaks it out into some tokens like command names, parameter names. But after that, it goes through this other phase, which is making an abstract syntax tree. And that's a tree-like structure that represents actually the structure of your script. So if you've got some commands inside of a for loop, well, there's going to be a tree-like representation of commands inside of a for loop. So you can do some just ridiculous intelligence against the AST, where you can't just maybe sometimes look at a regular expression. Maybe if you've got something that's part of a command name, it's bad, or a parameter name with a specific command name, maybe that's bad. So the amount of like opportunity and intelligence that you have here is just massive with the AST. One of the things that we played around with for Daniel Bohannon and I are going to talk about this tomorrow, revoke obfuscation. It's a whole talk, we're going to dig nice and deep into it, but you can do things like some crazy math on this AST or some crazy statistics on this AST, and you can get amazing tools on your back end that are automatically digging through scripts to find ones that are obfuscated. And every obfuscated script that you find, maybe that one is worth a bit deeper investigation. So post-processing event logs is amazing. There's another point here too, which is device guard and application whitelisting. People talk about, how do I prevent things like Mimikatz from working when it's been done in PowerShell, right? People say, well, I want to prevent access to all of the Win32 API. I want to prevent access to a bunch of stuff that I see that's sketchy. The answer here is through device guard and or an application whitelisting process. So when PowerShell launches, if it sees that you have a whitelisted application policy for PowerShell scripts, it automatically goes down to something called constrained language mode. Now, constrained language mode ends up being something that's kind of like cmd.exe, where it's like pretty basic. You can run commands, some very basic like for loops and that kind of stuff. But what you can't do, you can't run the add type command that lets you run arbitrary C#. And you can't run any of the .NET APIs that lets you dig around in memory and stuff. In fact, you can't run pretty much any .NET API. So this is an example of PowerShell when you have enabled application whitelisting for PowerShell scripts. At the top here is an example, very, very simple script, just raising a number to that number, right? Now, the bottom shows an example. That's a trusted script. Imagine that it was in device guard policy I had or something like that. When it's in guard policy, I can this works just it's from your IT staff, whatever, full access to PowerShell, the same way that you sign access to 32. Now, try to run any sort of .NET direct PowerShell instance. So it's going to say no, that .NET API is not allowed in constrained language mode. And you might move the file, maybe it was just have your policy, then that won't run. Bring the file itself won't run. So you still have the ability to use PowerShell to transparent for the still PowerShell for the stuff you don't. The truth is, not where with this frame, there are all things like create .NET APIs, process memory, all the doing with more details of restrictions. Element by access like fail break. If you've got access to so one of those
Hi folks, I'm Geek here. I think based on the sounds of what I'm seeing in the video, the microphone was going out. I hope they fixed it for the next talk that I'm about to process. So unfortunately, the rest of this video is blank as far as sound is concerned. Sorry for the inconvenience.